The challenging part about this problem is figure out the number of total outcomes. Now this one only has you think about it on one end of the problem, because look at it. It says Arizona State Lottery, a player chooses 6 different numbers from 1 to 41. Hey, 1 to 41. So how many total different numbers are there in the lottery? There's 41 of them. Okay. If these 6 numbers match the 6 numbers drawn by the lottery commission, the player wins. Or shares if they, someone else wins too. Okay, the top prize. What is the probability of winning? So, in this scenario, how many outcomes are desired? There's one outcome that's desired. It's your 6 numbers, right?
But just the order doesn't matter.
Oh yeah, but order doesn't matter. Yeah. Order doesn't matter. It just, doesn't matter what order the numbers come out. If you got your 6 numbers, you win. Okay, so that's kind of confusing, and that's the flaw in this problem, is that not everybody understands how lotteries work. Okay, so but anyways, we'll go as we go. Okay, so there's one. So for our probability for this event, our probability that we want for this event, and that's if you win. That's all the W is. That's if you win. Is one outcome out of what? Like how many total outcomes or possibilities are there? We know that there's 41 different numbers, but how many different ways can you get 6 of those numbers? Maybe you thought this. Did you guys think this? Did you guys think about 6 different numbers and choosing them 6 times? Did anybody do this? You're like, hey, for the first choice, like how many different numbers are there for the first choice? There's 41. And then how many different numbers are there for the second choice? 40, and then 39, and then 38, and then 37, and then 36. Now, that's going to be a ginormous number after I multiply all those together. This is a counting principle, right? But we got a problem here. Like, what is our number? Let's pretend our number is, 7, 12, and 13, just because you like those numbers. And then we got 23 in there. You got to do 39. I don't know why, but you got to. And then 30. I can't do 72. It has to be between 1 and 41. Okay, so here's 6 numbers. Let's pretend these are yours. Isn't this the same as? Aren't those the same? Now, but if we do this, it's going to count this one and this one as different outcomes. But we can't count them as different outcomes. And did you guys know that this, multiplying all those together, is the same as saying 41, choose 6, permutation 6? That's the same. It's the same. Because, check this out. It goes 41 factorial, and then you have 41 minus 6 factorial. And so you have, 35 factorial? So 35 times 34 times 33 times 32 times 31 all the way down to 1 gets canceled out in this, and then we get left with this stuff right here, right? Does that make sense? Yeah. All right. This is if order mattered, but order doesn't matter in a lottery. It just matters if those 6 numbers come out. So we cannot count these. And so how do I get rid of all the repeats? You put a 6 factorial right here. That takes out all the extras, because for every outcome, there's 6 factorial ways you can order those. And so we got to take all those out. So what do we do to find the answer? I'm going to show you. You just go 41, choose 6. That will give you the total number of possible outcomes. Now you can use a calculator for this, or you guys can actually do all the work, but it's going to be a pretty big number. So I was just throwing it into a calculator.
4 billion. I got for the ex5.
For what?
Yeah, that's right.
388?
Wait, what are you talking about?
Is that what this equals?
Yes. Oh no, that equals a really big.
Okay, so this is not right.
And then I divided it by.
All right, can you plug in your calculator, please? Okay, boom. Yeah, so if you do this, if you plug this in your calculator, you get that. You can also do it long ways, but that would suck.